Hey everyone, my name is Shashank Shekhar, Master Teacher of Mathematics at Vedantu. Here we are presenting solutions for JEE Advanced 2018 Paper 2. In this video, the question is related to the topic permutation and combination. Okay, and it involves the idea of function also, one function, onto functions. So let's have a look what the problem is. It says let capital X be the set with exactly 5 elements and capital Y be a set of exactly 7 elements. In set X there are 5 elements, in set Y there are 7 elements. If alpha is the number of one functions from the set X to set Y and beta represents the number of onto functions from Y to X. From Y to X, number of elements in Y is higher than number of elements in X. Obviously number of onto function from X to Y will not be defined, so here they are saying from Y to X, it is okay. Then the value of 1 upon 5 factorial times beta minus alpha. So we need to find alpha and beta first. It's very easy to find alpha and beta also, we'll see one by one. Okay, so first of all we'll find the value of alpha. For alpha, what we can do, alpha is, okay, let X be the elements as A1, A2, A3, A4 and A5. Y be another set having 7 elements, B1, B2, B7. So number of functions, or one function from, total number of function would be obviously 7 raised power 5, but number of one function, number of one functions from X to Y, that is, here we are representing it by alpha. So alpha must be okay, so we have to engage these 5 elements of X with exactly 5 elements of set Y, then only one function is possible, because no 2 elements are going with the same element of Y, no 2 element of X are going with the same element of Y, so they are taking different elements of Y. So total 5 elements of X will occupy 5 different elements of Y. So we need to select those 5 elements from set Y which are going to be engaged with the elements of X. So those 5 elements can be selected by 7C5 ways, and now we have correspond to every case of it. So we have 5 elements in X and 5 elements in Y chosen. So now we have to arrange these 5 elements of X to the selected 5 elements of Y. This can be done in 5 factorial ways. 5 factorial ways. So question is to find beta minus alpha by 5 factorial. So we'll keep it. So 7C5 is 7 into 6 by 2, that is 21. 21 into 5 factorial. 5 factorial can be written as this also. So beta upon 5 factorial is 21. Now let's see, this is alpha. Alpha upon 5 factorial is 21. Now how can you find beta? Beta is the number of onto functions from Y to X. There is a formula for getting onto function. But here if you go for the formula using the idea of principle of inclusion exclusion, I will discuss it later. So we'll find beta not using that formula, we'll find beta from the basics. So I am considering from Y to X now. So Y, there are 7 elements, B1, B2, B7. In X there are 5 elements, A1, A2, A5. So from Y to X, number of onto function is beta. Beta must be like, what can happen? Think about it. So every element of X is to be occupied, is to be engaged with at least one element of Y. So what will happen? Here there are 5 elements, here there are 7 elements. So there will arise 2 cases, like distribution of the 7 elements of Y with the elements of X will be like either three elements will go with exactly one element of X and remaining 1 1 1. So in this way, the five elements of X are like one element of X will be engaged with the three elements of Y, and the remaining four will be engaged with exactly one element of Y, remaining four elements of Y. Or it can be done in the other way, like 2 plus 2 plus 1 plus 1 plus 1. So 2 2 1 1 1. This is the way of the division. So you can divide 7 elements as into 5 groups as 2 2 1 1 1. So there are two elements of X which are going to be engaged with exactly two elements of Y, and remaining 3 with one element of Y. So if we go for the first method, using the formula of division distribution also you can do this, but I am doing it in another way. It's just nothing but the the idea of NCR. So selecting an element of X which are going to be engaged with three elements of Y. So what is that element taking three elements of Y? That can be selected in 5C1 ways. So I have selected one element of X which is going to be engaged with the three elements of which three elements of Y? You can select in 7C3 ways. So one element done, and remaining four elements of X with four elements of Y as 4 factorial, right? Second case is 2 2 1 1 1. So how can we find this? So there are two elements of X going to be engaged with two elements of Y. So what are those two elements of X? So we have to select it in 5C2 ways. Now for the very first element of those two selected elements of X, say it is we have selected A1 and A2. Now we will think over A1. A1 is going to take two elements of Y. Which two elements? So for that, 7C2. Select two elements from the set Y out of B1 to B7. So first element done. Now second element again taking two elements of Y is going to be engaged with two elements of Y. Which two elements of Y? So remaining 2 out of remaining 5C2 done. And now we are left with 3 elements of X and the 3 elements of Y. This can be done in 3 factorial ways. So what is beta upon 5 factorial? If you try to take common 5 factorial, then it is 5 factorial into 7C3, and this is, I think, 3 factorial is already there, so we have to write 4 into 5. If you write 10, 7C2 is 21, okay, 5C2 is again 10 into 3 factorial. So I'm writing 5 factorial over here, and 7C3 is 35. If you calculate it, 7 into 6 into 5 divided by 3 into 2 into 1, so that is 35, plus 20 into 3 factorial is 5 factorial, and we are left with 21 into 5, that is 105. So finally we are getting 5 factorial into 140 as the value of beta. However, beta can also be calculated using the formula of getting onto function, which comes from the idea of principle of inclusion exclusion. It says it must be 5 raised power 7 minus 5C1 into 4 raised power 7, total number of functions minus the cases when at least one element of X is not engaged with any element of Y. That can be chosen from 5C1 ways. So maximum 4 elements are engaged, so 4 raised power 7, plus because 2 are not engaged are also involved in it, so we have to add it again. So it is like this. So if you have some practice on the principle of inclusion exclusion, you can easily get beta as this. But again, I will say here it should be 3, here should be 4, 1 raised power 7. So beta can also be calculated like this, but again I will say the calculation part in this formula is higher. because you need to find 5 raised power 7, 4 raised power 7, 3 raised power 7. It's not common numbers to get. So beta is finally 5 factorial into 140. Final question was to get beta minus alpha upon 5 factorial. Alpha we got as 21 into 5 factorial, beta as 140 into 5 factorial. So answer to the question, beta minus alpha upon 5 factorial as 140 minus, it was 21 into 5 factorial divided by 5 factorial. So the answer to the question finally is 190. 140 minus 21, that is 190. Okay, got it? So right, I hope you understood this, the value of alpha, one function from x to y, and the value of beta, the onto function from y to x, right? Here you can use the formula of division and distribution also to get the value of beta. That is also okay. I hope you understood it, right? So thank you, stay tuned.